So what I'm going to talk about is another way to generate Taproot scripts. First off, my name is Steve Myers, and we're here to talk about Taproot output descriptors. So things I'm going to talk about today are why use an output descriptors, what are the pieces that make up an output descriptor, or the elements of a descriptor. I'll give some examples of what it looks like with a Taproot output descriptor. And then I'll just talk a little bit about what software currently supports Taproot descriptors, at least the ones I know about. And I'm actually looking for anybody that knows any other tools that can use make descriptor wallets with Taproot. And then a little bit about the future. I think some of it's already been covered, so I may not go into it too much. And then just some links, and we can have Q&A. Okay, so why would you want to use an output descriptor? Well, everybody, we just saw in the last presentation all of the elements that make up a Taproot descriptor. There's to actually create valid Bitcoin script, you need to know a lot about how to construct those scripts. So what descriptors do, for anybody who's not actually, here's a quick question: who knows what descriptors are? Okay, so most people know kind of what descriptors are. Who's used a descriptor wallet, a wallet with a descriptor in it? Someone in the back does. All right, someone's used Core.
Oh, yeah.
Yeah. So there aren't a lot of wallets right now that do it, but it gives you it's a very powerful way to create a wallet. One of the reasons it's powerful is that it's human readable if you're sort of an engineer. So it's readable and auditable without having to actually parse through all of the bits and bytes and control blocks and everything that make up a Bitcoin script. The other thing that's nice about descriptors is they ensure that you're going to have a well-formed script that's valid and does what you want it to do. So it won't let you make one that's too big or that's invalid. If you use a descriptor to define your wallet, you're going to get a valid bunch of output scripts from it. It works with PSBTs. And one of the other use cases where descriptors come in handy is, say, you have a wallet based on a particular descriptor and you want to use some other wallet software. You can take that descriptor, and it's a nice cross-platform way to take all of the spending conditions from one implementation and import it into another implementation and be pretty sure that it's going to be valid and you're not going to lose access to your coins. So it does this in sort of a nice, concise text format. It has checksums. So if you are transferring from one wallet to another, the checksum's valid or not valid, it's going to tell you. And it's standard-ish. I say standard-ish because not every wallet today implements every feature of the descriptors. So there is sort of a standard for descriptors, but it's not fully implemented everywhere. But the parts that are implemented should be the same. So that's why output descriptors are useful. Get this out of the way. So now we're going to talk about the details of what makes up a descriptor. When we say descriptor, I guess I should have prefaced this by saying what you're doing is you're coming up with a way of describing all of the output scripts that your wallet can spend to or can spend from. So, and then those output scripts can become addresses. So from a descriptor, you can create an address that somebody can spend to you, and then that you can then spend again in another output. What you can put into these descriptors, like how you can construct them, is it's essentially a root. You can have an optional, this first part is a key origin, which is optional. You can have a root fingerprint and an HD path. So where this might be coming in handy is if you have a hardware wallet or hardware signer, like back then better. And it has your root key in it for your HD path. So you don't have to put the root public key itself. You can just put its fingerprint, which is like a hash version, piece of a hash version, and then the HD path that you derived the actual key that you're using in your wallet. And I'll show sort of some examples of what that looks like. So you can have this optional key origin, which is great for hardware signers. And then you can have a key, which is potentially just a public key, or it could be a private key. You can actually, if you put a private key in a descriptor, it's not going to use the private key when it makes new receive addresses. It's going to use the public key version of that private key. So like if you're backing up your wallet on an HD descriptor, usually you're going to put the public key, keep the private key somewhere safe. The other thing you can put in a descriptor for the key part of a descriptor is a extended private key or public key. So this is BIP32. That means that you can have wildcards. So instead of just having a single key wallet, like just one public key, you can have, based on this path, you can have, a limited number of public private key pairs generated, the HD path. One BIP that is also Taproot related, that it's not related to making Taproot as the ones Lisa talked about. It's also this BIP86 is, if you've ever like BIP84, where it's the path you use in an HD wallet for defining where your key, the path to find your keys. This is more for like wallet interoperability. They have one for SegWit, they have one for legacy. BIP86 would be the path you would use for Taproot. So if you've got an xpriv or xpub, it's the purpose is 86. So that's Taproot only. The other thing that's new in Taproot for descriptors is you can do so Taproot uses X-only public keys. So descriptors, the descriptor sort of standard now supports X-only public keys for use in Taproot descriptor scripts or descriptor definitions. So that's like the key part of a descriptor. Can use all these different things, and then you have what are called top-level expressions. So descriptors basically allow you to define your scripts in a functional kind of way, like you're doing functional programming, sort of. So the legacy top-level scripts that you can define in a descriptor is, public key hash, script hash with a script inside, a script hash with a witness script hash with a script inside, or a script hash with a witness public key hash with a key. So these are all the kind of legacy top-level ways to define your scripts that your wallet's going to use. Then there's SegWit. So you have witness public key hash with just the key inside, or that, now I say key, again, that could be a WIF, or it could be a xpub or an xpriv, anything that's kind of key-like. The thing you can't put in there, if it's like SegWit, you can't put an X-only public key. That's only Taproot. Or a witness script, a script hash, which has a hash script or has a script defined in it. So this is new so what's new in this descriptor spec for Taproot is you can now have this top level script of TR, so Taproot. And what's unique, as we were just discussing, so in Taproot, you can have the key spend, and you can make a descriptor that does only a key spend. So say you just want one key or one xpub with a bunch of keys, or you can have an X key with this tree. And a tree is either a script or another tree that has scripts in it, or that whole tree of either getting more trees or more scripts. And you can define this in Taproot by basically using these curly brackets and then a comma separated list of either a script or another tree. So you can have nested trees within trees, or at any point put a script. Yes?
And there are one, two elements of the tree because I think have the selected there at the end.
Yes. So you can have more than, can you have more than two? I thought you could have more than two. Maybe.
Yeah, only have
Just two. Okay. That's a good point. So I guess I should take this part off.
What does that tree look like? That tree just defines the two branches that go off it, and like each branch leads to another tree.
Right. So it's just got to be, So basically what we're talking about is this. That needs to go away. Right? Yeah. So it's just.
The second element is optional, but if you could make it a variadic.
So this is, you could have just one script and then one tree and nested down the trees. Yeah, that makes, thank you right there. Oh, I didn't want to do that.
One more question.
Yeah.
So, what would a K event multi-sig using Frost or?
Right. So I'll talk about that. I'll show that in a minute. So these are I just described the top level things on how you organize keys or scripts. So I guess you could have a single key or a single script with another tree and do this arbitrary nesting within. So the part where I said script can have these elements. So you could, for the legacy Taproot or for the legacy descriptors, you could have just a public key in place of a script, or you could have a public key hash, or you could have this multi. So if you're doing legacy, you would use this multi statement where it's K of n keys, or sorted multi. So it's going to just sort the keys based on lexicographic, what number it is. Now, new for Taproot is you have this multi-A, which people don't think is going to be useful, but until we get another way to do it, it's useful. What's that? Yes. So A for add. So multi-add. So you can have a K of keys. It's just the Taproot way to do it. Yeah. So multi-add, it's basically the same thing, but it's doing it for Taproot. So under the covers, it's going to be a different opcode. It's going to be the Taproot opcode that we heard about earlier. But this is how you do it. So this is basically what you would use if you want to do a multi-sig as part of the branches in your tap tree. And then let's see what was this.
One benefit could be that it's just more private. It's not super exclusive like this is a multi-sig, right?
Yeah. So if you're just comparing it with legacy, so yeah, in legacy scripts, you would have to show the whole script even if you weren't using it. So in this tap tree, you could it's going to be one of your optional leafs. And if it's not the leaf you're using, no one's going to see it. Like, so say you have a key on one side and a leaf on the other, a script, a multi-A on the other leaf, and you only use the key, you're not going to see it. So, yeah.
Essentially dumb question, but so with these descriptors, you are committing to being allowed to spend any arbitrary branch in the tap script, or is it only single branch that you're putting in?
You're basically making scripts where you can satisfy the script with any of the branch, meeting any of the conditions. Either you can like on one branch you have a key, and on the other branch you have this multi-A. You can either solve it with a key, or you can solve it by giving 2 out of 3 or whatever.
So if we were to go back to the last talk, a descriptor would have all of those like top equal verify scripts embedded in all 4 of those embedded in the script, right?
Right. It would make scripts for all of those options. I guess it's making scripts for all those that you can satisfy with any of those options.
So you should think you need all of these scripts to produce Taproot scripts.
Right. Like the thing you're going to back up, like say you had a wallet and you're backing it up, you need to back up the whole descriptor that has all those options, so you know all of the potential keys, for instance, or scripts you would need to satisfy the script. So we talked about, so these are things that go inside the script elements within the trees. So then this is going to be a kind of short talk maybe, but so these are just some examples. So just so you can see like nuts and bolts what it looks like. These are just Taproot examples. And these work with core. Like I've tested these. These are the test conditions. If you go look at the spec too, like they're kind of the common ones. But so you start with Taproot. That means, what did I just do? Taproot. And then in this case, it's an XPub. So we're using an XPub with a wildcard at the end. So you could have a wallet, and then there's the last piece with the pound symbol. That's the hash. So if you were to this is like defines a wallet with a whole bunch of scripts that you can get addresses for and then spend from. So that's simple. So this is only a key spend. So this example right here is just a key spend. The next example, it still starts with Taproot. We have a key spend at the beginning, this first part. So it's another, So in this case, it's just a X-only pub key. That's what so there's just one key, just one public-private key pair at the top of the tree. But then in the first leaf of the tree, we just have actually one leaf in this one. So just one leaf. It's we need to satisfy a public key, and it's using tpriv. And that's a wildcard. And then, what did I miss here? Oh, no, sorry. This does have 2 leaves. So it's got 2 leaves. You've got 2 different, you've got an xpriv, and then you've got just another XOR public key. And those are your 2 branches that you would have to satisfy. So this one also produces an unlimited number of output scripts because we have this one wildcard in one of the branches. And then it's a hash too.
So one thing that's different about this is that it's actually the private key in this one.
Yes.
It's a mix of private and public.
But what's going to actually, even if you put a private key, it's going to, when it actually makes the scripts, it's going to use the public key. So whether you put a public key or private key, you're going to get some results.
But so I guess just an observation. Mm-hmm. This is like a more powerful descriptor because you can actually sign with
Yes, yes, exactly. So if you're using this in a wallet, you can sign with this one, right? And there is, like when you create a wallet in Core, a descriptor wallet for Taproot, there's a parameter I think you need to give it to say that it's a wallet that you want to be able to spend from. Otherwise, it's not going to save the private version of your key. It's going to save the public version. There's, I think, an option for that.
There's the TPRV that just saves
Yeah.
an extended private key, T-Pub, like X-Pub, that's Pub.
Yeah, so that's right. So this is tpriv. And if it was, yeah, and also it's good. Yeah, and it's good to mention too that T means it's on testnet or reg testnet or, and then if it's xpriv, then it's mainnet. Question back. Right. So so if you don't put a wild card, then it's only going to be like, it's always going to give you the same address from your wallet, for instance, because it's only going to be one script. With a wild card, then it's going to produce, an unlimited number relatively. Yes. Yeah, think of it like an index variable, and it's going to, and every 1, 2, 3, 4, 5. That's each one going to produce a different script, a different HD, and a different HD public key, a different public key from that hierarchy, that HD. Yes.
Can you specify how deep the derivation path may be and whether or not the path should be hardened or not?
Yes, I don't think I have an example, but I probably should have put one in. So in this spec, this BIP 86 and similar BIPs, you do specify in the HD derivation scheme, you can have hardened and non-hardened steps. And in the hardened steps, you produce a public-private key pair that can then produce additional derivations. I believe that's how it works. But if it's a non-hardened derivation, you can't go and derive additional derivations, something like that. You can go deeper with public. Oh, you can't go back.
With a hardened path, you can only produce a hardened path if you have a private key.
Yes, that's it, right.
If you have a bunch of, if you have a relation of the private key off the top root node or somewhere along the way on a hard derivation.
Yeah.
And then you can calculate it. Actually, if you have a better relation somewhere that's deeper down the line, you can from that calculate the higher.
Right. So so if you have like hardened step 1, hardened step 2, hardened step 3, and you're trying to derive from those hardened steps, you need the private key. If you're just at the if you have hardened, and then non-hardened, and you're just trying to derive from there, you don't need the private key for the unhardened step. So yeah, I didn't get into that, but basically all of the rules that applied to legacy in terms of HD derivation paths, it's all the same for Taproot. So, and so I don't think so this last example is where we get to the multi-A within a tap tree node. So we again have our key spend at the beginning, and then we have, in this case, we just have one leaf of our tree, and it's the sorted multi-A, and then we have the number 2, which means we need to have 2 valid signatures, and then we have 3 different pub keys here. And actually, now that I look at this one, it's only going to ever produce one address because we don't have any wildcards here. So we just have this one that starts with 2F and the one that starts with 5C. So this is basically a 2 of 2 multi-sig. It could be a 2 of 3, but we just have a 2 of 2 here. And it's always going to produce the same. Like if you had it in a wallet, it's always going to produce the same deposit address because there's no wildcards, there's no indexes, there's no HD derivation here. So, yeah.
One other thing that Steve was asking, what's the hash?
Oh yeah, sorry, yeah.
That's just like protection. I understand it's just protection.
Yep.
It's like copy paste there. Just look at check.
Right. So if you were using this,
I think
it's a checksum, yeah.
4 bytes, just so you don't copy paste.
Yeah. So if you were using this as your backup for your wallet,
If you're trying to type it out.
and you wanted to type it out for some reason, or so the fingerprint was for the root key of an HD XPub, like XPub or XPriv. So yeah, those are two. Yeah. So yeah, all of this stuff. Yeah.
It's like unrelated to what's inside the descriptor. It's just like checksum for the whole thing itself.
Yeah, the fingerprint had to do with the key origin for the HD keys. Yeah, and that checksum is optional. You don't need a checksum.
Like it's so, context. Yeah. Sometimes Bitcoin Core won't let you.
That's true. I guess
it's unclear when it's required.
Yeah, like you can put in a descriptor without a checksum and have Core generate the checksum for you for those places where it needs it.
There's like get descriptor. There's another
get descriptor info.
You can express a certain descriptor in a couple different ways. It's exactly the same. There's an idea of like making them canonical. There's like a canonical way
to make a descriptor. You mean like just for a Taproot?
For example, like a sorted multi with multiple XPubs.
Right.
It doesn't matter what order they're in.
Right.
It's exactly the same thing.
Right.
So there's like some canonical like.
Yeah, and actually that's true. If you had a sorted multi and then you had just a multi, but you sorted them yourself, they would be basically the same. I think.
Exactly. So there's like a canonical representation.
Yeah.
That's one of the things that like get descriptor info thing in Bitcoin Core.
To give you, it does that for you? I didn't know that.
Well, you can put a descriptor in, and then you'll get a different one back.
They can rental your descriptor.
Too,
yeah.
But like it'll order the XPubs, for example.
Oh, that's interesting. I never noticed it did that.
That sorted multi, that's just before, like, to generate the redeem script.
To generate the redeem script, right?
It orders the public inside of there.
Yeah.
So that if you back it up, it's going to
right. Well, yeah. Right. I mean, I think this would be an example where, say, you don't share your descriptor with somebody. You just say, oh, we're going to do a 2 of 3 and these are the keys. And then they just happen to pick a different order. And I've done this before when I'm like testing myself and I'm like, oh, I just did it in a different order and it's not working. But if you do sorted, like, I think there's no really reason not to use sorted unless your implementation doesn't support it for some reason. But lexicographically, so basically every key can be considered a number.
So if you have an XPub, right? When you have 3 XPubs, you will pass that index to the star, basically. So you have first index, second index, third index, right? Now you have like actual pub keys, not XPub, like concrete specific pub keys, and those can be ordered differently. You can't know that ahead of time. So you have to
that's true too, right.
And then you order those, like the chat, whatever it's there, or whatever it's called. But the SEC pub key, like the static serialization pub key, is not an XPub, it's like the child pub key. Yeah, the compressed pub key, you order those. And this is like, the big thing here is like the cold card makes you do that. The other ones don't, so.
So yeah, for interoperability, I think sorted is generally a good approach. Yeah. Especially if you're using, like you said, if you're using wildcards, because you don't know what they're going to be ahead of time anyway. So those are just simple examples. I originally wanted to have a slide on how to use miniscript, because if technically you should also be able to use miniscript to define the scripts within the tap trees. I just didn't have time to like figure out an example that worked. So, but that also should work. And Core does not support miniscript. I work on BDK, Bitcoin Dev Kit, which does support miniscript, and we are using miniscript in our Taproot stuff. We just hasn't been well tested. So that's my next thing is, so like, what software supports this stuff? Like, where can you go play with this? You can do it in Core 23, the latest one out, or maybe there's 23.1 now. But anyway, you can do this now. You can make a Taproot descriptor wallet, and you can give it a descriptor with TR parenthesis, and then generate addresses and receive and spend and do all the good stuff like that. It only supports this kind of limited subset that I just described here with the multi and keys, basically. Bitcoin, just as of last week, we got version 019 out, which does support Taproot. So it's using Rust Bitcoin, the latest version of Rust Bitcoin and the latest version of Rust Miniscript, which have support for Taproot. And we're calling it experimental because, like I said, we haven't tested every scenario, especially with the Miniscript stuff, which has a lot more functionality, a lot of, like, you can do logical operations and all sorts of things in Miniscript. But, you know, we'll get there. We'll just get it tested, and we need to expand that, but that's a thing to do. Also for BDK or Bitcoin Dev Kit, we don't yet have it in the CLI, but we'll have it in the CLI pretty soon. I have a branch where I just upgraded the CLI to do it. So I was like testing all this stuff that way. And then eventually we'll have this in our mobile bindings. So if you're working on a Android wallet or a Swift wallet, iOS wallet, theoretically you can now use Taproot and make a Taproot wallet on your phone. And if anybody knows of any others, please let me know, because I'm looking to collect other things we can interoperability test BDK with. We tested against Core, but we haven't tested against anything else because I couldn't find anything else that does Taproot descriptors. So maybe there's Python or something. I don't know.
Yeah, on the Bitcoin Core side, there's currently a bunch of pull requests open to add mini-script.
Okay. Oh, that's good to
They're
know.
mostly open, so if you
Okay.
want to
Go play with that.
this, like, that is actually a pretty good opportunity.
Yeah. Okay. So we have some branches that we can play with.
So,
Okay.
Peter Willa made a mini-script library in C++ like a couple years ago, and that was recently, like, parts of that are something were merged into Bitcoin Core, but it's not used yet.
Okay.
So now there's one about, like, using it to produce addresses, using it to sign.
Right.
So there's like there's a handful of different pull requests. So it's an interesting, if you want to learn more of that.
Yeah. And that's actually another thing that if they're going to be supporting Miniscript, we should interoperability test all that. I'm pretty sure it's going to work. But Andrew. Oh, 5 minutes. Okay. I just have a couple more slides. So it's already been talked about earlier today. Sort of the future is more likely to be something like Musig 2, which means you don't need to do like for 2 of 2s, 3 of 3s, 4 of 4s, whatever. You can do it without actually having any script involved. You can just combine the keys. And then maybe something also for doing thresholds would be Frost. So if we have Frost and we have Musig, and you can go ahead and do all that just with the keys, then if all you need is multisig, then you don't need some of the ops I showed, some of the expressions I showed. But you might still, this is one of the tests I want to try. I don't know if anybody else has tried to do this, but I wanted to try to do a tap tree script that has a time lock and a key. You should be able to do that. But I haven't figured out quite how yet. But that would be something that you can't do with Musig 2 or Frost. Like you could combine Musig or Frost with that, but to do a time lock, you're going to have to do, I think, different opcode. I mean, you have to actually do a time lock. So yeah. And then I guess we'll share these slides somewhere. And these are just all the links that I use to research this stuff. Yeah. And that's also my Twitter, not mandatory. So that's it. Any other questions? I know we kind of did questions in the middle, but anybody else had anything else they wanted to know? Rust, I might have some here. Let me see. Let's see. I think I have it on my other machine, but I was in the process of, you want to see just like how, so this is another thing that BDK has is we have a descriptor macro. So you can literally write your Taproot script in this macro, and it'll create a descriptor that you can then use to create your wallet. So that's probably the most interesting thing to look at. So in the descriptor module here, we have our DSLs, and then if we go down to our tests, where is it? Okay, thanks. Anyway, we just have two here. So here's an example of a Taproot descriptor made from the macro. You just say Taproot. We have our private key. This one was created from a WIF. And then we have the leaf. The first leaf is a PK private key, and then another PK private key. So this is like simple example. And then we're just verifying here that it produces a valid, Taproot string. I think it even puts it even does the hash. Now what you would do if you were making a BDK wallet is in the wallet constructor, you just put in a descriptor string, or you put in this actually produces a descriptor structure. You just put in that structure and then that's it. Similarly, I think we have another example. What's this one? It's just a single leaf. You just have a single leaf example. But yeah, the other place where we have some tests is yeah. So the first one's the key pass spend. This is the key pass spend. And you can see it was made from a WIF. So it's a public, it gets the public key from that. The other thing is in our test suite here, I'm just going to show this. Ooh, you said 12? Never use that. No, that doesn't work. So we have some tests here where in our test suite, we actually made we made in core a descriptor wallet. So it actually spins up a version of core, makes a descriptor wallet, creates a descriptor, creates a PSBT, and then it sends that PSBT back to the BDK library. And we make sure that we can actually, what did we do here? I think it's the other way around. I think what did I do here? Yeah, and we make the descriptor wallet, and then we get the PSBT, and then we make sure we can read the PSBT, and it's valid in BDK. Oh, we compare it. That's what we do. We make the same one in both. So we make a BDK PSBT, and then we do it here and make sure it works. So yeah, so we have a few tests like that. But the scripts we have right now in our test suite are simple. One of the goals I have is to make some more complicated scripts with some of these multi-sigs and stuff like that. So
Your previous example, I saw your path the private key Taproot script.
Yep.
You said earlier that it turns it into the public key.
Right. To make your scripts that your output scripts.
Why would you pass in the public key and not just seems like more safe than just get the
Well, you might have a watch wallet, for instance. So say you have a watch wallet or some application that only needs to watch the blockchain. It doesn't actually need to make spending transactions. Then you would just have the public key in the descriptor. That's probably the most useful case. There might be other ones, but definitely for a watch kind of scenario. If you spend so the other scenario is like when you're talking about what you're going to back up, you probably want to back up your descriptor with your public keys in it. And then you're going to have your seed words, for instance, to have the actual root key that, you don't back that up at all. It's just a hardware device. So all you're ever going to put in your descriptors are always going to be the public keys. You're going to create a PSBT from those to do any spending transactions, pass that to your hardware signer. You're never going to put that in your descriptor. You're always going to have public keys. So I actually would say public keys for most scenarios is most common. But again, if you have like a little, a small balance wallet on your phone, maybe you will use private keys, something like that. It might be easier, and BDK supports it both ways, and so does Core. So, okay, that's it. Thank you all.